Hello everyone and welcome back to the channel. In today's video, we'll explore the architecture of AmbuSens system and understand how its different layers work together, from sensor nodes and communication networks to cloud servers and user dashboards. Each component plays an important role in real-time environmental monitoring. So let's get started and discover how the complete AmbuSens architecture operates. So here the AmbuSens system, it is a healthcare Internet of Things platform which is developed to provide continuous monitoring of patients, especially during the transportation between the hospitals. And it is it uses the physiological sensors, cloud computing and secure data management to ensure the real-time healthcare services. And the architecture of AmbuSens, it is divided into 4 layers. Each performing specific task. That is, first layer, here it is the WBAN and the LDPU which collect the physiological data and it's sent to the cloud. Then second is the healthcare cloud which stores, processes and analyzes the health data. Third layer is the identity management unit which ensures security and patient anonymity. Then you have last layer, that is the fourth layer, it is the medical personnel where access there will be access and use to patients' data. Now we'll see these all one by one in detail. So here the first layer, it is the WBAN, that is the wireless body area network layer. And this layer, it is responsible for collecting the physiological data from the patient and transmitting it to the next level of the architecture, next level of the healthcare IoT system. Now here you can see that a patient is lying on the hospital bed while wearing multiple sensors here, okay? And these sensors continuously monitor the important health parameters such as the ECG, then blood pressure, body temperature, SpO2, that is the oxygen saturation, and the respiration rate. So each sensor performs a specific task and collects a different type of physiological information. Since the sensors measure different parameters, they are referred to as the heterogeneous sensors. Now, before collecting the data, the sensors undergo calibration, okay, which is highlighted here, calibration. Here the calibration ensures that the sensors provide accurate and reliable measurements. And accurate sensor readings are very essential because incorrect data may lead to improper diagnosis and the treatment. And here you can see the WBAN where all the physical sensors communicate wirelessly, okay, here. And here via WBAN formation, okay, wirelessly with the local data processing unit. The LDPU, it acts as a local hub that will receive the data simultaneously from all these multiple sensors attached to the patient's body. And the wireless communication module, it will eliminate the need for complex wiring and makes the monitoring process more comfortable and flexible for the patient. Now, once the LDPU receives the physiological data, it performs basic processing and the validation of the collected information. Now, the processed data is then transmitted securely to the healthcare cloud through a wireless connection. Okay. Now, the cloud, it stores the information and makes it available for further analysis by the healthcare professionals. Here you can see that here we get the summary of this first layer. That is the physiological parameters. Then we have the sensor calibration, WBAN formation, okay, here. Then you have the data collection and reliable local processing by the LDPU and data forwarding to the cloud, okay. So here this first layer, it serves as the foundation of the AmbuSens system by enabling continuous health monitoring, accurate data collection and reliable transmission of the patient information to higher layers for storage, analysis and the medical decision making. Then second layer is the healthcare cloud layer. So here this layer serves as the central processing and the storage unit of the AmbuSens healthcare IoT system. So it is its primary role is to receive the health data from multiple patients through a wireless body area networks and perform storage, processing and analysis of the collected information. Now here you can see there are multiple patients wearing the physiological sensor that will continuously monitor the vital signs such as the heart rate, then you have blood pressure, oxygen saturation, and the temperature. Now the data which is collected from these sensors are transmitted to the healthcare cloud through the wireless communication. Since the data arrive from many patients simultaneously, the cloud must efficiently manage large volumes of healthcare information. Now, here you can see the major functions of the healthcare cloud. The first function is the data aggregation, where the information received from multiple WBANs is collected and combined into a unified data set. Then next, you have the data standardization, where it converts the data into a common format so that the information from the different devices and sensors can be processed consistently. Okay, here. Then next you have the next stage is the storage of the health records, where both current and historical patient records are securely maintained, and this long-term storage helps doctors track patient health over extended periods. And another function is the virtual machine initiation, that is where it provides the scalable computing resources whenever additional processing power is needed, and this allows the system to handle increasing amount of healthcare data efficiently. And the final function is the big data analytics, that is using advanced analytical techniques. The cloud processes the large data sets and generates meaningful insights about the patient health, and real-time analysis enable the early detection of health abnormalities and supports timely medical intervention. So here you can see how the doctors and the healthcare professionals use the analyzed information. That is, the cloud provides the real-time insights, supports better diagnosis and treatment decisions, and enables a long-term patient-specific analysis. So here you can say that the healthcare cloud layer, it acts as an intelligence center of the AmbuSens system by providing the scalable storage, powerful computation, secure management, that is the data management, and real-time analytics. And this layer, it helps the healthcare professionals make informed decisions while ensuring efficient and continuous patient monitoring. Then next layer is the identity management layer. It is a third layer, and here it is responsible for maintaining the security, privacy, and confidentiality, and the confidentiality of the patient information which is stored in the healthcare cloud. Now, since the healthcare data, it contains very sensitive or highly sensitive personal and medical information, protecting the patient's identity is a crucial requirement here. Now here you can see that the patient data received from the healthcare cloud layer is shown entering the identity management layer. Okay, here. Now this data may include both like it includes health records, vital signs, then medical reports, and historical patient information. And before the data can be accessed or shared, the patient's identity must be protected. Okay, so the first step shown in the image is anonymous patient identification, or the ID, where instead of storing a patient's real identity directly, the system, it will hide the personal details and assigns an anonymous identity, and this prevents unauthorized individuals from linking medical records to a specific patient. Then comes the dynamic hash generation, where a unique hash value, which is a coded representation. Okay, here it is a coded representation of the patient's identity, and it is generated for every patient. And this hash acts as a secure identifier and replaces the actual identity information of the system. Then the third stage is the periodic hash update. To enhance the security, the generated hash values, okay, these are not permanent, they change automatically at different levels or the intervals, and this dynamic hashing mechanism makes it extremely difficult for the attackers to trace or identify a patient using stored records. And the fourth stage is identity mapping and authentication, and this process, it securely maintains the relationship between the real patient identity and the generated hash values. And authentication mechanisms, these verify users before granting access to any information. So only authorized healthcare professionals can access the patient data. Now here you can see that the patient records are stored securely in the cloud using the hash values instead of the real identities. So as a result, unauthorized users cannot directly identify the patients from the stored information. Now here these are the key benefits of the identity management layer. So these include the patient's privacy, protection, prevention of unauthorized access, then secure authentication, dynamic security through changing hash values, and enhanced confidentiality. So overall we can say that the layer 3, it serves as the security backbone of the AmbuSens system by ensuring that sensitive healthcare information remains protected while allowing the authorized users to access it safely and efficiently. Next you have layer 4, that is the user layer, and it is the topmost layer of the system, and it serves as an interface between the healthcare system and its users. So here it consists of authorized healthcare personnel who can access the patient information and through the AmbuSens cloud platform. Okay, here. And here you can see that different categories of registered users are shown here, including the doctors, nurses, then medical specialists, and the hospital administrators. These users access the patient information which is stored in the AmbuSens cloud according to their roles and the responsibilities. So the cloud acts as a central repository where patients' records, reports, and monitoring data are securely stored, and those are made available to the authorized personnel. Now here you can see the major activities which are performed by the users through the AmbuSens system. Healthcare professional can monitor the patient health conditions using the real-time physiological data collected from the sensors, and they can also view the real-time reports that provide the current information about the patient's vital signs and overall health status. And in addition, users can analyze the historical data or the records, allowing them to study previous medical conditions and treatments and also the health trends. Now here the healthcare professionals can provide the medical recommendations, okay, based on the analyzed data and make appropriate treatment decisions. And access to comprehensive patient information enables doctors and specialists to offer better diagnosis and personalized healthcare services. Now on the right side here you can see that the one of the important features of the user layer, that is the multiple doctors can access the same patient's information simultaneously from the different locations. Okay, now since all the data are stored in the cloud here, healthcare professionals can collaborate in real time regardless of their geographical location, and this feature particularly it is useful during the emergencies, then consultations, and the specialist referrals. So these are the key benefits. First is the secure access to patient data, then real-time monitoring and alerts. You have easy access to historical data, then collaborative decision making and access from anywhere, anytime. So the layer 4, it acts as the decision making and application layer of the AmbuSens system, and it enables healthcare professionals to efficiently access, analyze, and utilize the patient information, leading to faster diagnosis, improved treatment planning, and better healthcare. So that's a complete overview of the AmbuSens system architecture. I hope this video helped you to understand how the data flows from the sensors to the cloud for the real-time monitoring and the analysis. If you found this explanation useful, please like, share, and subscribe for more videos on IoT, smart sensing, and embedded systems. Thanks for watching, and I will see you in the next video. Thank you.